Absolutely.
And I hope, goodness, everybody's here. You can see that you're really popular, Alex. See all these folks showing up on a Tuesday.
I
Tuesday
love
in the
it.
middle of farm season too. Like these are folks that are busy in the farm season.
Hey, yeah, this is amazing. Love having everybody here tonight. So
If everybody could put their name and organization, change their name and organization on their Zoom, just so that folks know who you are. In specific, Alex knows who you are since we all know each other. You're outnumbered, Alex. All right. I think we can go ahead and get started. Alex, if you want to start by introducing yourself and what you do, and then I'll start off with a few specific questions, and then we'll get, I'm sure, a zillion questions from the audience.
Perfect. That sounds great. My name is Alex Nusser. I work for Bargreen Ellingson. I design and build commercial kitchens, restaurants, and commissary kitchens. I work with um, public and private sector. I work with state funded projects, privately funded projects, um, and I do everything from space planning, taking an architect's shell and assisting my customers with designing the space to fit their needs for the future. And that includes custom stainless, exhaust hoods, exhaust systems, um, walk-in custom storage, keg storage, custom beer systems, stainless products, and millwork. So pretty much everything within the building envelope, I have my hands into. My normal daily life. So it's a fun industry, and I enjoy the diversity of what we do, and yeah. So um, yeah, walk-in coolers and freezers are are one avenue that I've spent a lot of time in over the last decade. When I started out in the industry, I was um, coming from being a refrigeration mechanic, HVAC tech. Um, and so, my experience in the past, made it a little bit more intimate for me when I started designing and planning for walk-in coolers and freezers for different types of builds. So, yeah, um, definitely enjoy the challenges and the creativity involved.
Thank you. So Alex, this particular group, a lot of folks on this call received some funding from the Oregon Food Hub Network, which was funded by the Oregon Legislature
Uh-huh.
to expand their infrastructure. And these particular folks on this call are interested in building their cold storage facilities, or not facilities, but building a cold storage unit.
Okay.
Could you walk us through what is the process of building a cold storage unit? If Christy Athens, who's on this call, said, "Hey, Alex, I want to build a cold storage unit. What do I do?" What
Yes,
would you walk her through to get the conversation going?
absolutely. So first off, I'd like to know what size, what is Christy plan on putting in the walk-in? How much space does she need right now, and how much growth does she need for the future? Um, Walk-ins come in all shapes and sizes, so we could do standard cooler. Standard coolers have 4-inch thick walls, whereas freezers have 5-inch thick walls. And we have so if the panel is 4 inches thick, we'll have 20 gauge metal on the exterior, uh, 20 gauge metal on the interior. That's at the factory, they're built in a form and impregnated with foam with a cam system so that these panels can then be shipped to your project location. And then my team would assemble these panels and lock them all together and build this build a building on your property. So typically with a cooler, we are slab on grade constructions. We would require a concrete slab to begin with. It's best if the cooler or freezer is inside some sort of building to protect the shell from the elements. We can do, and I have done many outdoor walk-in coolers and freezers. However, the lifespan becomes greatly depreciated when you have the solar wearing on that surface 365 days a year. So if that building could be constructed inside even a pole barn, having that exterior shell to protect the roof and the walls, your walk-in could last up to 25 years, 20 to 25 years. Whereas if it's out in the elements, it may be depreciated by 10 to 12 years. So yeah, I would like to know what products are going inside, and how much space we need if you're going to be driving a forklift into the walk-in. We can do a standard doors or 3.0 doors, but we can do virtually any size door. We can do high-speed roll-up doors that are that have heated frames so that they don't ice up and just become less problematic for day-to-day use. So yeah.
So most of our folks, I can say almost certainly are not going to be doing high-speed doors with heated frames. We're
Yes.
probably more like most of us. Carrie might be an exception because she's a farmer as well as a small-scale distributor.
Okay.
Most of us are probably going to be on the order of a restaurant walk-in size, ranging from that, 10 to 15, 10 by 15 to 20 by 25, that kind
Yeah.
of probably. I'm making some guesses. So maybe the next step would be to have Christy, if you wanted to just answer some of those questions, describe your operation, then Alex can walk us through his conversation. So if you want to describe what you're putting in it, where it's going to be, what size maybe you kind of think it would be, and then Alex can talk you through what the steps would be to get you on the road to ordering that.
Yep.
What you need to have on your property, ordering that, who and how it's contracted, what sort of electrical you need to have on place on your property before you can get into contracting. I think those are
Absolutely.
the things that we're trying to look for, those whammy points
Okay.
in actually building the thing. And then of course at some point we'll want to talk about lead times. So Christy, if you want to do a quick description of what you do and how your operation works, I think that would be a helpful leaping point.
Sure. Hi, can you hear me? I got a giant monitor and I can't control the volume, so I just want to make sure. So I actually have a bargaining quote. I would love to ask you about that later. From Sean Britt. But it's a 12 by 8. It's in a shop. It does have a slab. I've had the electrician and a general contractor come out and look. And so, I'm interested in the fact that you thought you would send a team out to build it, because my thought was the general contractor would do that. So I'd love to hear about that. And I'm out in Wallowa County.
Okay.
And it does have 3-phase, but my understanding is 1-phase is better. I would love to understand that better.
Absolutely.
Okay.
Yeah. So
anything else?
yeah, no, that's great. That's great. Sean's actually a good friend of mine. I've known him for a very long time. And yeah, for a 12 by 8, that's a relatively small walk-in. That could be built in a day. We have personnel that can build it in-house, and then we also have other tradesmen, general contractors in the area that can also build it. In your environment, typically in the valley, building department wants to see seismic engineering, so they're going to want to see load calcs, attachment points for that walk-in because it's over 4 feet. It's over 4 feet tall. So the rule of thumb is 4 feet, 400 pounds or 70 pounds suspended requires engineering. And it's not to, depending on typically like, and that's just typical to the valley. Um, and yeah, so single phase versus three phase power. Three phase, so higher volts, um, you're going to draw less amps, therefore it's going to run more efficiently. Whereas, single phase is more readily available and typically more common. Most people don't have three phase power. And then to upgrade would be cost prohibitive to have three phase power, have a transformer put in to be able to change phase on your property would probably be cost prohibitive. So if you have three phase right now, I would suggest going with three phase just because cost of ownership long term will be less for the mechanical equipment. And for a standard cooler, the condensing unit, which would be your outdoor unit, that would be that would take three phase power. Your evaporator coil that hangs inside the walk-in cooler that's expelling the heat out of the space, that's going to be typically with a cooler, especially that size, is most likely going to be 120 volt, less than a 30 amp service. So that's pretty common. The lighting in the walk-in would be an LED lighting. And that's not going to draw more than a couple amps. It's very, very low. And that's about it. Coolers are very simple. Freezers have more nuisances with them. Evaporator coils tend to be 208 or 240 instead of 120 volt. And the condensed units can be 208 or 240 single phase or 208, 240 three phase. So you get into larger service requirements for the additional cooling power that you have in a freezer. But
Yeah, I should specify that I'm looking for a combo unit.
okay. And in your case, then you would have a condensing unit for the cooler, a condensing unit for the freezer, both outside of the building so they can expel the heat outdoors most efficiently. You'd have the evaporator coil in the freezer, which is going to be 208 or 240 single phase or three phase. And then, yeah, you're going to have door heat within the frame for the freezer to keep that door from freezing closed. You're also going to have another circuit behind your evaporator coil in the freezer that wraps the condensate line that comes off the evaporator coil. So as it's condensing within the space and dripping in the drip pan of the evaporator coil, it doesn't freeze within the space and it's allowed to drain outside of the walk-in. Because otherwise it'll fill up with ice and overflow into the space, and that's a huge nuisance. So yeah, that's kind of it in a nutshell. Freezer, so for this size walk-in, a 12 by 8's relatively small. However, your cooler be slab on grade, be right on the concrete. The freezer could either be on grade with an insulated floor that would be 4 inches thick with a 3/4 ply wear surface with an anti-slip surface on top, like an aluminum wear surface. Or if you wanted, like, not in your case, if you had a larger walk-in, we could do a subgrade slab. So a general contractor could excavate down about 18 inches, put in a rat slab about 6 inches thick, create this pit that we would build up with. We'd have a asphalt emulsion layer in the bottom. Then we'd have 3 layers of 2-inch insulation. And then we have another layer of felt paper. And then the general contractor would then pour 6 inches of concrete on top of that so that floor would plane with the cooler. However, it would be an insulated floor so that we wouldn't have any issues with pulling in moisture into that freezer. So it would encapsulate that freezer envelope and keep it nice and cold in there.
Can I chime in with a question real quick?
Absolutely.
pertaining to what you were just talking about, is that for an exterior install, or could that also pertain to an interior install? And would there be benefits to doing that if there's already a concrete slab?
Yes. So it just kind of depends on what you're using it for. So if your freezer is indoor, outdoor, it's required to have an insulated floor, no matter what. If you're driving forklifts in and out, if you're, if you're an institution, every school that I've ever built, we have, a standard subgrade floor application because it lasts longer. The wear surface it doesn't get compromised by pallets going in and out or hand trucks or because over time an on grade insulated floor will eventually break down, whereas concrete is less likely to over years of use. Other applications, like if you have a cooler that's not on grade, say it's on a second story of a building, you would then need to add an insulated floor to the cooler. It couldn't be slab on grade because of the potential for it to sweat through through cracks in the concrete and potentially cause damage to the building. But yes, all freezers would have an insulated floor, whether they're in interior or exterior of the building envelope.
What other questions do we have about building walk-ins? I know we had a bunch of questions. Alex, what are we not asking you that we don't know that we don't know?
Yeah, so walk-ins are the size of the walk-in really depends on the application. There's some walk-ins that we've done in Hood River that are, 300 square feet, 300 feet by 300 feet, 24 feet tall, that we'll do inside of a tilt-up building with, polystyrene foam versus polyurethane foam. So we can do just about anything based on storage needs. And it just kind of determines, based on the application, will determine the type of products we use. So for most restaurant size walk-ins, we would use a polyurethane mold injected panel that I would take that 12 by 8 dimension, get a factory quote, share that with my customer. We kind of talk about where it's going on the property. I'd come out and field measure it to make sure that there's no obstacles I'm not seeing. There's no columns in the way or building structure issues that I need to measure around and create a notch in the walk-in for. And then I would have that walk-in released to fabrication. My team would then receive it at one of my Bargrain locations. We'd coordinate with you for the delivery, show up on the site, build the walk-in in that structure, that envelope, building envelope. And then I would have my refrigeration mechanics come in, pipe it, put it on pressure test. We'd have our city inspections, and then we'd start up the system and final test it to meet health code. So to make sure that temperatures are pulled down and that we're holding coolers are at 34 degrees, freezers are at -10 degrees. But we can adjust temperature set points based on the product as well. So if I've done wine coolers before for vineyards, and we've had large wine warehouses that we adjust the temperature, and we can also add heat to the walk-ins to create humidity control. So there's other things we can do to fine tune and be more specialized to the application.
Amy, I think you had your hand up first, then Carrie, then Christy.
Yeah, thanks. Hi, Alex. This is Amy from the Oregon Department of Agriculture. I'm in the marketing program, so non-regulatory stuff.
Nice to
Um,
meet you.
yeah, nice to meet you. My question is about, you mentioned earlier that you at times work with local contractors, possibly, in the region or community where, you may be working on this built-in project.
Yeah,
So I was curious to hear, I guess I have two questions. I was curious to hear a little bit more about that, like the network of contractors that you're working with and the different types of services they provide. And then my second question, I guess, is maybe an add-on to that one. A lot of times when I'm out visiting with folks, processors or food makers, also food hubs, a lot of the questions I get asked are about resources to really maximize efficiency in kind of the workflow of the operation. And I'm just sort of curious, what like the whole like scope of what your company might provide in terms of you're mentioning that you help with the architecture or the design, right? Does
yes,
that also include things like, principles of like lean manufacturing, where you're really trying to help these companies or these businesses,
yeah,
figure out those workflows, or do you also work with some local contractors to do that?
I
But I just
do.
wondered if you could speak to that a little bit.
Yes. So I work with a variety of different users. I work with chefs, I work with contractors, architects, and you know, I'll be brought in at times, for casinos, existing establishments. Chefs will say, "Hey, Alex, what do you think?" Food service directors will say, "Hey, Alex, what do you think of our normal operation? How we're functioning right now? Um, what would you change if you were to make any recommendations?" And I'll come in and kind of look at that workflow and see kind of just watch people and how they're operating in that day-to-day environment, because sometimes, we have our best intentions at the beginning of a project and the way we're designing things, and maybe we have constraints budget wise or schedule wise that guide us one direction when, the most efficient method would take longer. And, with every project has a deadline that we need to meet for all sorts of reasons. So sometimes that's what's guiding our hand to complete a project a certain way that we wouldn't otherwise. So it's fun. I really enjoy taking a project and because typically when I'm originally at the beginning of becoming contracted to a job, um, I may speak with a chef or a food service director about what their goals are for the space or the concept. And then I'll get a shell drawing, which is just that building envelope or the space outline for the kitchen or bar application. And then I'll work with my team of designers in house and we'll go, okay, we want to put the kitchen here and we're going to have flow in and out this area. And we're going to put the scullery, the dish room in this space, and bakery is going to go over here. And we just kind of figured out based on their model, what their restaurant or space is trying to deliver, just so that we can keep everything fluid within that space and have more control of that environment. Um, making it more efficient, less steps. So yeah, that's kind of how that works. I started out as a carpenter in the trades, cabinet maker, carpenter, and so for me, I have a plumber in the family, uh, electrician in the family. I was a refrigeration tech as well. So I'm very hands-on. So I like working with trades. I communicate really well with them. And so um, in the Portland area, I have like 5 different install teams I use on the regular. But I too also like to be on site during install days and bags on because I find it enjoyable to, get out there and keep building and staying sharp. So yeah. But yeah, my team, if we were to become contracted to build a walk-in for you per se, um, my team could handle everything from once we've solidified the design and I have as-built drawings, I would then put together, permit set, give that to my contractor to submit to the city so that they'd be responsible during the process, the building process. So once the walls are built, we could have, inspection at that point, to the mechanical inspection for the refrigeration part of it. I've worked with a number of electricians in the Portland area. So typically the electricians would carry their own permit for that connection, for that service. If your property, most residential property is, single phase power. So they come in and they would evaluate what you have. Maybe you have to run a sub panel off your main to that location for the mechanical equipment and have a disconnect there within site per mechanical code. So we would check all those boxes and make sure that we have that whole, outline defined prior to, moving forward. So, yeah.
Yeah, thank you. I appreciate that.
Absolutely.
I also was curious, and then I know there's some other questions here, but have you, it may be, you mentioned the health department, I think, but I'm curious if there's been any other, if you had to interface with ODA at all, with food safety in any of your projects before?
I haven't.
Yeah, I didn't think I didn't think so, but I
Yeah.
was just curious about that, if that had ever come up.
I'll assist my customers, if I'm doing a grocery application or if we were doing an agricultural based walk-in, I'd be there to help along the way, but typically the end user would interface with Department of Ag or the health department, um, you know, fill out the permit and go through those last steps because they're going to be the one that's going to be carrying on ownership of that product for the future. So
Mhm.
I'd be there to definitely help you get over that hurdle, but I wouldn't be the one that they would be reaching out to every time there's an inspection per se.
Yeah. Okay, thanks.
Cool, you're welcome.
Carrie.
Hi, I'm here. Can you hear me?
Loud and clear.
Yes,
Okay.
you're packing boxes, right?
I am. Yes, I haven't hired my helper yet, so I'm running very late. But yeah, I'm packing boxes. So I have a comment about walk-ins. I am very fortunate to have one. I built it myself. It's a CoolBot.
Okay.
But for those who are considering saving money by not getting a floor, definitely get a floor. Thought I could save $1,500 by just putting it right on the concrete. And it really struggles, even with a 12,000 BTU AC unit. It has a really hard time staying cold.
Yeah.
So I'm constantly like opening windows and shutting windows and opening doors and trying to ventilate and putting fans, and it's exhausting. So definitely get an insulated floor.
And part of that has to do with having a CoolBot, because CoolBots I know that are kind of somewhat acceptable on more of an agricultural side, but like for the commercial world, I've never seen one in the 10 years that I've been building commercial projects. And it's just because of the infrastructure behind it. You're relying on a air conditioner unit, a PTAC unit to cool the space. And you could build in redundancy with CoolBots, but I think that just the way that mechanical code has been adopted into the commercial building sector, it's just it doesn't have the robust background to be able to provide that cooling to ensure that product is going to stay within that safe zone for
It worked great for 2 years, but we're 5 years out now, and it's really struggling. You're gonna have to replace that AC unit like every 2-3 years if you go that route.
Yeah.
And my question, as I'm shopping as well as the other folks on this call, I'm actually looking for a reach-in freezer, not a walk-in. So my questions were, about like the top units versus the bottom units. There's like, you can put the compressor, I guess you can get a bottom compressor or a top compressor, and then there's all these different types of refrigerant options. And like, what are the advantages or disadvantages of those?
Yes. I prefer top mount just because it's expelling the heat that much easier. It's not expelling low and then the heat rises. So I mean, if you're sticking the freezer in a shop, for instance, that's open, I would just do a top mount. Sometimes, if we have a built-in, say, if the freezer is going into a restaurant and it's being recessed into, say, an alcove and there's a bank of freezers, bottom mount compressor might be nice because then it's expelling the heat out the front. A lot of the time when I do under counter and back bar refrigeration, we'll have the heat discharging out the front of the unit instead of the back of the unit because you can run into issues long term. You can get premature failure on the compressor side if it's not expelling that heat efficiently. So other things that can be done are adjusting, having an HVAC contractor come in, adjust the heat within the, adjust that space, rebalance that zone to allow that unit to be able to expel more efficiently. And then refrigeration it seems like it's constantly changing every couple of years. Right now, the big hit is R290, which is propane. And the Department of Energy has a mandate on how much refrigerant you can physically have in the units. You can only have so many ounces of refrigerant because it's flammable, but very, very efficient. And then, of course, for larger process refrigeration and, big cold storage units, they're going now to, CO2, as well as, there's some other mediums that they're using that are just less common in the smaller units. Whereas in the past they were using refrigerants that had more of a ozone. They were more less environmentally friendly. So yeah, that's one benefit to going with R290 on a closed system of that size. So yeah.
Is that something that has to be replaced? I mean, like in maintenance?
Not unless, no. So, the only maintenance required on a self-contained unit, like a self-contained freezer like that, would be to you quarterly check the condenser coil and just clean the fins with a coil brush. It's either like a nylon or a wire brush, and you just go with the coils run vertically. You just kind of sweep the coils just to keep lint off of them and allow that condenser coil to work more efficiently.
Okay, thank you.
Yeah, absolutely.
Christy.
So many questions. So I'm trying to think of questions that would be useful to others. It's not too specific to my thing, but so my shop has 12-foot ceilings. So we were originally talking about piping the condensers out of the building, but then the consensus was that was not necessary, that they could be top mounted and actually provide some heat in the shop, which is unheated during winter.
They can.
And I do want to point out, I am very, very far away from the Willamette Valley. I'm in Wallowa County.
Oh, okay.
Northeast corner. So I'm not in the city. And I highly doubt you and your team want to come out here. It's 6 hours away from Bend. So do you also just sell units and not the whole?
We can do kind of a blend, and my team will go virtually anywhere I have, ask them to go. So it's
Yeah, but
at the
I
end
don't
of the
want to
day,
pay for that, and you don't want to
Yeah.
pay for that.
Yeah, I mean, finding a refrigeration mechanic in your market can be a little bit more tricky if you're more rural. Sorry, I thought you said you were from Aloha earlier, and I was thinking, oh, that's in the
Uh-huh.
Valley, near Hillsboro.
Yeah,
Yeah.
Yeah.
But in the Wallowas, yeah.
So I have a contractor. He will get the electrician, he will get the refrigeration, And you're absolutely correct. The closest refrigeration person is, I don't even know where
Boise.
these days.
Yeah.
It's horrible. But yeah, I just wanted to make sure that was an option.
Absolutely.
And I have a couple of quotes. I originally went through Arctic manufacturing website, and then they
Yeah.
shunted me over to Bargreen, and that's how I got in touch with Sean. Or
Yeah.
Sean got in touch with me. And then I also have one from Bar, which is in Wisconsin.
Okay. Yeah.
Um,
And Arctic is actually an offshoot of a company called Imperial Brown, which is local to Gresham. They started out in
Ah.
Gresham, Oregon. Arctic is more of it's their more economical. It's what we call a soft nose walk-in. It's
A
a
what?
blend, a soft nose, soft
nose.
rail. And what it is it's a blend of polystyrene and polyurethane. So it's a mold injected panel, but it's a blend of foam. So they don't last as long as a polyurethane molded walk-in cooler would, um, which is considered a hard rail walk-in. So just take that into consideration. They tend to be, a little bit less and quite a bit less in cost for the Arctic, comparable walk-in. However, if you're planning on keeping this walk-in for many, many years to come, I would recommend going with the standard hard rail polyurethane um, walk-in versus the blended soft nose walk-in from Arctic.
And so those are new terms. The term that I have heard over the course of doing this is closed cell. Is that?
Yes. Yeah. So closed cell. Yeah. I mean, that's another term for it. The hard nose, soft nose, it has to do with how the density of the foam. And so, yeah, Arctics just aren't as dense as the polyurethane hard railed walk-in, the standard spec line from Imperial Brown. They're just, yeah, they just don't last quite as long.
Okay. Cool. And then what height do you recommend? One of my quotes, the height was like 7 feet, and the other one is 10.5. And I was like,
Yeah.
okay, I'm 5 feet tall. What am I gonna do with that top 5 feet of room?
A standard height is 8'6". Spec line walk-ins for a lot of the schools I've built are 10 feet. And what it has to do with is the shelving within the unit. If you have shelving that's 72 inches with 6-inch casters on it, it just becomes a little bit more difficult to store as much product. You can store more product in a 10-foot walk-in. Plus, your evaporator coil is hanging from the ceiling, so that's going to also impact shelving in the space. So it's just helpful long term, just to be able to.
How far down does the thing hang?
They hang about 6. They're for a 10 by 12 cooler or 10 by 12 freezer. We're going to say that it hangs down probably 18 to 20 inches in the space.
That's a lot.
Yeah. They're about 36 inches to 40 inches wide, depending on the size. They'll have either a single fan or 2 fans. Sometimes you'll have if it was a 10 by 20, you may have multiple coils. You might have 2 in there with 4 fans. So it just kind of depends on that space. Yep.
And then so I'm planning on putting in a combo unit. It's the space is 12 feet deep. So my thought was the first 2/3 would be the cooler and the last third would be the freezer. Do you have any feedback on that? I pitched it to these guys and they're all just like, okay. But I'm like, does that sound good?
It sounds small because that freezer is only going to be 4 feet. 4 feet deep. Cooler's 8 feet deep.
Yeah.
Yeah, it's gonna be a very small space. I mean, and then how wide is it? It's 8 feet wide.
8 feet.
Yeah, so 4 by 8 with that coil in there. I mean, it's gonna, the door will swing out into the cooler. So you'll open up the door to the cooler, walk down an aisle, so you won't be able to put anything in the middle. And then you'll have shelving on the sides, and then you'll open up the door to the freezer, and then it'll be the evaporator coil right there, right in front of you.
Yeah.
And you'll have two little shelving units in there and maybe a smaller shelving unit underneath the coil on the
Mhm.
back wall.
So would you, I mean, that's the space I have, so, but that's good feedback. So would it be smarter to put the door on the side? Rather
I
than
think
in the
it's
middle?
better to put it in the middle.
Okay.
Just because I think that'll allow more flexibility on storage for your shelving
Okay.
layout.
Alright, so there'll
But
be
yeah,
sort
I
of a
mean,
traffic lane and then some storage on the sides.
right. I mean, because typically, like if the walk-in is, shaped, it's a rectangle, you would have the evaporator coil on the back. So when you open up the door, like say it's just a cooler, you'd open up the door and the evaporator coil would be all the way across from you. So it's circulating that air throughout the
Uh-huh.
length of the
But this is
space.
such a small space.
Right. It's not going to be I mean, it's going to be a small space. It's going to circulate. It's going to stay cold, but you're just going to be limited on how much storage you have. And it is what it
Yeah.
is for what you're dealing with. But, for the cooler that you're walking through, the evaporator coil is going to need to be on the side, and that's going to impact shelving on the side. And it's going to circulate, but it's not going to circulate as efficiently as it would if it was just a cooler. And
Mhm.
the evaporator if you did just an 8 by 12 cooler with the evaporator coil on the far end, then it would circulate more efficiently. You'd have more space for shelving because you wouldn't have the door for the freezer.
Right. It's gonna be all evaporator coils and doors at this.
Yeah, it might make more sense just to do an 8 by 12 cooler and then get a standalone freezer. And
Yeah.
then you're saving money on the mechanical that you're not doing for that freezer. That's, purchase cost wise, space wise, you just have to weigh that out for yourself. How much frozen product do you need on hand, and does it make sense? How is it coming in? What type of products are you storing in there, etc. So
Yeah, okay, that's good info. Thank you. I appreciate it.
Alex, we have about 3 questions I think that have gone into the chat. One is about moving walk-ins. Is there a walk-in that is easy-ish to move if you are planning on moving spaces?
Yep.
The other is there a minimum size at which walk-in is not a great choice, which we may have kind of covered?
Yes.
And the other is, are there cost efficiency associated with build size, i.e. going taller in an existing footprint?
Okay. Yes. So, for moving a walk-in, it's best not to move a walk-in once it's built, because of the process there. It has kind of like a dovetail joint where the panels lock together, where the cam locks. Then there's a mechanical fastener that you put an Allen wrench in, and you crank over this crank that hooks and ties those two panels together. And that gasket material in between, you're also adding silicone or butyl to really seal that penetration. So to try to take it apart, to move it, relocate it somewhere else, it can break apart later. I have worked with customers that are adamant that they are going to want to move it at some point. And so we don't apply silicone or butyl in between those two cams. And so it could be taken apart. I have seen walk-ins move. My team has moved walk-ins successfully, but it's just there's so much potential for it to not seal as well as it did when you initially put it together once you move it. So, sometimes what I'll suggest is that we build it on a flatbed trailer, so that we can maybe park it at the location, kind of like a food cart, keep it there. Maybe, even we could do top mount refrigeration. It's what's called a capsule pack unit. It's a self-contained unit, kind of like a self-contained cooler freezer, except one of the ceiling panels would have all your refrigeration mechanical in it. It would have that evaporator coil and condensing unit all interconnected, and it would have a cord and plug on it. So you just have your electrician put that service near wherever you're going to park that walk-in outside, and it would lock in, and you could theoretically be able to run it there, unplug it, hook it up to your trailer, hook it up to your vehicle, move it to another location if needed. I would say when you're looking at some walk-ins, some of the quick ship models you see online that are 6x6 or 6x8, they're pretty small. And for if you're paying a mechanic to come in and pipe the system and you're going through the permitting associated with it, it doesn't seem to really make a lot of sense to build a custom walk-in of that size. In my opinion, it's probably more economical long-term just to get a self-contained 2-door cooler to put in the space, or 2-door freezer. I personally don't like 3-door freezers or coolers because they're very difficult to move. They don't fit through doorways or buildings very efficiently. And just 2-door units seem more readily available, more economical, just across the board. The only caveat to that is just you're expelling the heat that's generated from that refrigeration process into that space that unit's sitting. So that's where a traditional walk-in with the outdoor unit expelling the heat outside of the building envelope is more efficient long-term. Did I miss one of the questions?
Minimum size, or sorry, you just did minimum size.
Yep.
Efficiency, cost efficiency around building taller on an existing footprint. And then I had dropped a timeline question in there for everyone
Okay.
as well.
Yeah, so timeline right now, it's right about 4 to 6 week lead time from approval drawings. So once we're contracted, we've dealt with everything on the financial side of things. We have shop drawings. When we sign off, I send them into the factory with the approvals. It's about 4 to 6 weeks to get that walk-in, back on site, ready for construction.
And design phase, how long would you estimate it? I know it can take as long as your entrepreneur takes, but if your entrepreneur is being efficient in communication, how long does a design phase take with you?
Maybe 2 weeks, 2 weeks total for that process. Yeah.
And then it'll go to get drawn, and so you'll get shop drawings in another couple of weeks from there. Okay.
Yeah. So if you were to reach out to me tomorrow and say, Alex, I want to build a walk-in here, I want an 8x12, I would then reach out to the factory and say, we need an 8x12, standard height, standard 3.0 door. I would specify the finishes. So a standard finish would be Galvalume interior and exterior. However, we can do Galvalume's looks kind of like aluminum foil, but it's 20 gauge metal. It wears well. It's the most economical. We can also do like a stucco white finish, which is the next up in cost. We can do a smooth white, so it looks like smooth FRP, which is really nice to clean. And then we can also cloud it with stainless. So we can do a number of different types of finishes. We can have a door with no window. We can have a door with a view window so that you can see inside the walk-in. All walk-ins are equipped with panic hardware so that if, the smaller the walk-in, the easier it is, or the more difficult it is to open the door. When you go inside and you shut the door, it creates a vacuum and there's no air getting in or out. So you can feel the pressure, and it can be difficult sometimes to open the door. So what we do is one of the code requirements for egress is there's panic hardware. So there's this mechanical hardware right next to the door, and it's painted with this it's painted with a paint so it glow in the dark paint. So if the lights happen to go out, you're stuck in the walk-in, you can find the door and push this button, which causes the hardware basically to come off from the inside so you can get out. One of the other things we do is we'll put this vent on the actual walk-in near the door. So if you had a smaller space, like an 8x8 walk-in or smaller, and it creates that vacuum, it then has an heated air vent basically, so that it doesn't create as tight of a vacuum in the space, so you can actually get out of you don't have that back pressure as you're trying to push against the door.
You get a lot of thumbs up on the Panic hardware. We have a few more minutes, not very many. Do we have any other questions, specific or otherwise, that this group wants to get out on the table while we have the amazing Alex, who knows everything there is about knocking together walk-ins on this
This is
call?
actually
Alex, it's so fun listening to you.
this is actually one of those heated door vents. I happen to have one underneath my desk here. So this vent would go and be mounted on the exterior of the box, and you'd have this piece that's heated so that it doesn't ice up, and there's a louver on the inside so that it keeps from creating a vacuum within the space, so you can actually open up the door if you're anyway.
Right. Other questions from this group? Christy, do you feel like you have a wealth of new information to work through your decision making with?
Yeah, I'm really, well, I'm kind of annoyed with the the people who sent me the 2 quotes I have, because neither of them said what you said. Like, have you thought about what this is gonna actually look like? Like, there's gonna be a door, there's gonna be a thing in your face, there's gonna be another door. You're not gonna have room to put anything.
Yeah, well, I've built hundreds of walk-ins. I've done a lot of schools over the last 10 years. And then I've done from spec line walk-ins to, when I have a customer who says, no, I'm adamant, I want this size box. And I try to talk them through, the difficulties that they may be faced with going with that size walk-in. They get it. And then it's like, okay, well, this is what we're dealing with now. So I like to try to put all that out front just so that my customers know, and they can decide, you can decide what's going to work best for you, what you're getting into.
Yeah.
And for folks on this call, I have in fact built a lot of walk-ins and built a lot of kitchens and built a lot of facilities. I am happy to look at any of your drawings or your specs before you push go, and give you another opinion outside of your salesperson's opinion about where that door is going, or ask some of those questions if you are feeling like you want that. Or I'm guessing from this call, you are going to understand that those are questions and whammy points you want to take a look at before you sign a contract.
Yeah. One other thing I didn't touch on is, so the exterior of your walk-in. So when we build walk-ins in a kitchen, and it's, typically there'll be like a recessed space that will have our walk-in. So it looks like it just planes with the other walls within the kitchen. That area that we're building the walk-in into, we have to allow minimum 2-inch airspace from the exterior of that wall to the building wall. And I prefer 3 inches on any adjoining exterior walls, just because of airflow requirements around that walk-in to keep it from potentially sweating and damaging the building as well, because it can cause problems long term within the building.
Oh, I'm not muted. So you're saying, because that's exactly what I have. I have a built out thing, and I'm gonna stick it in the middle.
Yeah.
So you're saying I would need 2 inches of clearance on either side?
Yes, you want 2 inches on the sides and on the
In the back?
Yes. And then for the height, say you have 9 feet to work with, we'll build the walls first, and then the ceiling panels need to slide over the wall panels and leapfrog down and then be cammed into the wall panels. So in order for that to happen, if they're 4-inch thick panels, it's good to have another 6 inches above the walk-in so we can actually work and maneuver those panels in.
Uh-huh.
And then typically, like in commercial buildings, the ceiling may be 16 feet and we're building an 8'6" walk-in. So all the electrician's connections would be on top of the walk-in. So they would run the circuit for the light, the evaporator coil, all that on top, so it's concealed and not inside the walk-in. Because any electrical connections on the inside of the walk-in have to be through a liquid type conduit, so there's no moisture. Because sometimes what happens, I've seen this over the years, where electricians don't seal that penetration. They've run the conduit overhead, drop it through for the lights, and then over time that light fixture stops working. And I pull the cover and it's full of water. And it's because of condensation, that temperature differential from inside to outside causes it to sweat inside of that light fixture, and then it just fills up with water until it starts dripping on the floor. So the way around that is to use a liquid type conduit, and then any penetration from inside to outside, they put they seal that penetration with silicone.
Awesome. Any one last question? Oh, we've got something in the.
I have to jump off, but I just wanted to thank Alex, and also I may be in touch just to connect him to a customer that I was meeting with in Eastern Oregon, just to see if there's any opportunity to share resources or potentially work together in the future. I think he's in some of the early stages of a building expansion project. But I've got your email from Sydney's announcement about this event, and I may be in touch, Alex. So thank
Great.
you. This was super
Thanks,
informative.
Amy.
Yeah.
Anytime. Yeah.
Anyone else?
Can you put your contact info in the chat?
Yeah. I'd be happy to send out my my contact info. Absolutely.
It's also on the calendar invite, Christy.
Oh, perfect.
Oh, okay.
Alex, thank you so much. This was hugely helpful, and I think, I know you can't answer everybody's questions in high technical detail, especially when they come at you in a round like this, but just getting all of that information out will help people approach the process in a much better way, I think, more realistic way.
Well, there's so many details, and it's definitely an area that I've seen over the years. A lot of my colleagues miss something along the way, and they're
complicated. They're building a building.
Exactly.
Really.
You're building a building. So anytime anybody has any questions, they're more than welcome to reach out to me. Happy to help.
Awesome. I appreciate your time so much.
Thank you.
All right.
Awesome.
Take care.
Take care.
See y'all. Bye, Christy.